Hi everyone, so this is question 13. Question 13, tutorial sheet 4. So the question says the matrix A is given as that. Then show that A satisfies the equation A to the power 3 being equal to 13A minus 12I. So this I is the identity matrix. That's what we've been told. So we can start. So I think A cubed, meaning we're going to multiply this matrix here 3 times. So we'll have something like this. So I'm going to multiply this 3 times. So this is what is going to so when I multiply this 2 times, and then I'll come and multiply the answer with this same one again. So I'm going to have 3 times 3 there. 3 times 3, I'm getting 9. Then 0 times 0, 0 times 0, I'll still get zeros. I move on to the next one there. 3 times 0 to be 0. 0 times 0, 0 times negative 1, 0. 0 times 3, I'll still get a 0 there. So I'll just put a 0 there. Same applies to the last column there. 3 times 0 to be 0, plus 0 times 2, 0, plus 0 times negative 2, I'll still get a 0. So I'll put a 9 there, and then I move on to the next row. So this will be 0 times 3, that will be 0. So I'll put my 0 there. Negative 1 times negative 1, I will get a positive 2, or positive 1, sorry. This 2, oh, I think I've made a mistake. This is 0 times 0 times 3, I'm getting a 0. Then negative 1 times 0, I'll still get a 0 there. Then this 2 times that 0, I'm still getting a 0 there, which is just the same as just writing a 0. So instead of me doing that, I'll just put a 0 there, and then I'll do the last row there. 0 times 3 will be 0. 3 times 0, 0. Negative 2 times 0, I'll still get a 0. So I'll put another 0 there. I move on now to the next column there with the second row here. So it will be 0 times 0, 0, and then negative 1 times negative 1, that will be a positive 1, and then 2 times 3. So 2 times 3, that will be a positive 6. Yeah, to be a positive 6. So when I add 1 plus 6 there, I'll get a 7. So I'm putting a 7 there. I move on to the last column there. So I'm going to have 0 times 0, 0, negative 1 times 2, I'm getting negative 2. And then 2 times negative 2, I'm getting negative 4. So when I add the 2, I'm getting negative 6. So instead I'll just write negative 6 there. Then I'm moving to the last row here. So there I'm going to have 0 times that 0, it will still give me a 0. 3 times negative 1, I'll get negative 3. And then I'll have this negative 2 times negative 3, this negative 2 times times positive 3 there, I'm getting negative 6. So when I add these, I'm getting negative 9. Yeah. So yeah, to give me negative 9. Then I move on to the last column there. So this will be 0 times 0 to give me 0, 3 times 2 to give me 6. So 6 plus negative 2 times negative 2, that's 4. So 6 plus 4, you get your answer to be 10. So this is the one that we should now multiply with another same matrix as this one. So I'm going to copy this. Let me just copy this. Okay, and then let me just put it here. I'm going to multiply this with this matrix again. Let me also copy one of these matrices. So, let me just do this. Let me just copy it very quickly. So this matrix is 3, 0, then 0. I'm going to have a 0 there, negative 1, 2. I'm going to have a 0, 3, negative 2 there. And then we multiply. So this is going to be 9 times 3. I'm going to get 27. Then this will be 0 times 0, 0 times then you still get the same zeros. So I'll just write 27 and forget there. Then I'll move on to the next one here. So this will be 0 times 3, 0, 7 times 0, 0, negative 6 times 0. So meaning here I'll still get a 0. And then I move on to the last part here. 0 times 0, 0 times 3, I'll get a 0. And then negative 9 times 0, 0, 10 times 0, I'm still getting a 0 there. So this is the matrix that we're finding. Let me just move it a bit like this. So we move on to the next column there. So 9 times 0 is 0, 0 times 1, 0, 0 times 3 to still give me a 0 there. So we can also do the last part. 0 times 9 times 0 still give me 0. 0 times 2 still 0. 0 times negative 2 still 0. So I'm having another 0 there. So this is going to now be the second column, the second row here, to find the second column number that is going to be here. So this is going to be 0 times 0 to be 0, then 7 times negative 1 to be negative 7, negative 6 times 3, it is going to be negative 18. So negative 7 minus 18, you get your answer to be, so negative 7 minus 18, your answer is negative 25. And then we also find what is going to be here. So it's going to be 0 times 0, 0, 7 times 2, that's 14, negative 6 times negative 2, I'm getting 12, so 12 plus 14, I'm getting 26 there. Move on to this one here. So it's going to be 0 times 0 to be 0, negative 9 times 1, negative 1 to be 9, 10 times 3, 30, 30 plus 9 to give me 39 there. Then we move on to the last number there to be 0 times 0, 0, negative 9 times 2, that's negative 18, then 10 times negative 2 to be negative 20, minus negative 18, you get your negative 38 there. So this is this is what we have. This is what we have, our a cubed. So this is a cubed. Let's now also try to find this part now. 13 times a, then minus, okay, let me just put this properly. Yeah, so I'm going to find now what 13 times a is going to be. So I'm going to multiply all the numbers in a by 13. So 3 times 13 there will be 39. So I'm trying to find 13a. So 13a is going to be equal to 3 times 13 times 3 there will give me 39, and then 13 times 0, 0, 13 times 0, 0, 13 times 0 there, 0, 13 times 0 there, 0, 13 times negative 1, I'm getting negative 13 there, and then I also have 13 times 3, there is also 39 there, 13 times negative 2, there is negative 26, and then 2 times 13, there's 26 here. So here now, this is what we're going to now subtract. This is what we're going to now, let me also find the, what's this, 12i. So 12i, let me just write it properly. So 12i is nothing but 12 times the identity matrix for a 3 by 3 matrix, which is this. So when you multiply this times that, you get 12 there, you get another 12, you get another 12, then the remaining ones are going to be zeros. So this is what we're going to subtract from 13a. So in short, what we're trying to say is 13a minus 12 is going to be equal to, so 13a is just this matrix there, which is 39, and then you have 0, 0, then you have that negative 13 there, you have 26, you have another 26, but this one is negative, and then you have 39 there, then you have a 0 there. So this is 13a. Then they are saying we subtract this from this 13a. So I'll write this matrix here. So this is what we're going to have. So here it's just the matter of subtracting now. So you subtract the corresponding entries. So 39 minus 12, you are going to have 27 there. 0 minus 0, you have 0. 0 minus 0, you have 0. And then 0 minus 0 there, you have 0. Negative 13 minus 12, you have negative 25. And then 26 minus 0, you have 26 there. 39 minus 0, you have 39 there. Then you have a 0. Yeah, you have a 0 there. Then you have negative 26 minus 12, you have negative 38. So when you look at this this matrix here, isn't it just the same as this matrix that we found here? This one here, which is a to the power 3. Of course, it's just the same. So meaning this can also be written as a to the power 3. Hence shown. So we have shown that 13a minus 12 is just the same as a to the power 3. I forgot to put I here. We have shown that. So let's see what the next question is saying. Assuming that A inverse exists, show that the equation in I can be written as 1 over 12 and then 13i minus I cubed. So we begin. So here what they are saying, they are asking us to show that A inverse is just given by this. How do you do that? So I'm going to write this expression here that has been given, saying A to the power 3 is nothing but equal to 13a minus 12i. And then from there, I'm going to take this 13 this side. So I'm going to have a to the power 3 minus 13a is equal to negative 12. So this negative 12 can also be written as just negative, this negative 12i can also be written as just negative 12, because an identity matrix in matrices is just a special one. So when you multiply any number or any matrix with this identity matrix, you still get the same matrix. So same applies to say when you multiply any number with its identity number, which is 1, you still get that same number. So it says this identity matrix is just a special one in matrices. So I can even write this negative 12 just as this negative 12i as just 12i. So I'll factorize this a out, and then I'm going to have Yeah, before I factorize, actually, let me first divide by -1 on all sides. I'll divide by -1, so meaning I'm going to have 3a this side, and then minus a to the power 3 being equal to 12. Then from there I'll factorize the a. Oh sorry, this is supposed to be 13, not 3. So I'll factorize the a there, so I'm going to remain with 13. And remember, this 13 is a constant. Now since we're dealing with matrices, I'll not leave it as this. I'll put the I there to show that this is a matrix as well. So minus, in short, when you are solving identities, you should have the third I. You should know where you are going. So I've put this I because I've seen this I this side, and this I is just a special one in matrices. And I removed this I from 12 because I know that I mean that my 12 here has no I. And then I'm going to have 13i minus a squared is going to be equal to 12. So from there now I'll divide everything. So I'm going to divide everything this side by 12, and then also divide by a, so that this a cancels with that a. So whatever I do to this side, I'm also doing it to the other side of the equal sign. So this will be 12a. I'm writing 12a this side. So this 12 and that 12 will cancel. But mind you, here I'm going to remain with 1 on top. So 1 over a can also be written as 1 to the power -1 is equal to, so this can also be written as 1 over 12 multiplied by 13 minus a squared. So this is 13i minus a squared. So from here the question is saying hence find the A inverse. So meaning what I'm going to do here, we're just going to find the inverse of this matrix by using this same given expression. So my inverse, let me just demarcate here. So the inverse of this matrix is now going to be equal to 1 over 12, and then I'm going to have first this. So 13 times I is just the same as having 13. Look at what happened when we were finding 12 times I. 12 times I gave us 12s on the leading diagonal. You can see this is 12 times I. It gave us 12 on the leading diagonal. So meaning 13 times I will give us 13 on the leading diagonal like that. So let me just write this matrix properly. So I'm going to have 13 on the leading diagonal. You have that, and then I'll subtract a squared. My a squared, if you remember, we found a squared at some point. A squared was here, which is 9, 7, 10, like that. Let me just copy it here. So this is going to be 9, 0, 0, you have 0, you have 7, you have -9, then you have 0, -6, and 10. So you're going to have 0, -6, and 10 there. So this is what we're going to have. So here it's just a matter of subtracting now to find the determinant, to find the inverse of this matrix. So we're going to have 1 over 12 outside like that. Then apart from this, now this will be 13 minus 9. You get your answer to be 4. Then 0 minus 0, you write your 0. 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0. 13 minus 7, you get your answer to be 6. And then you have 0 minus 6, you get your answer to be 6. Then 0 minus 9, you get your answer to be 9. Then here you have 13 minus 10, you get your answer to be 3. So this is going to be your A inverse. So thank you very much for watching the video. Make sure that you don't forget to subscribe to the channel, and if you have any concerns, any questions, you can forward them to this WhatsApp line on the screen here, and I'll be there to respond. See you in the next tutorial video.